Hello, this is Keenan Park, and this is Whitelock 7th grade worksheet lesson 24. So, unfortunately, it's going to be a little bit interesting today, as none of these multiple choice questions have an answer, but we will make do. So, we have the diameter of a circular sumo wrestling ring, which is 14.9 feet 14.9 feet. And so, we want to find the area of the sumo wrestling ring. So, hopefully, you guys know the formula. Area is equal to pi r squared. Now, unfortunately, they do not give us the radius. R is the radius. They give us the diameter instead. But it's really easy to find that the radius from the diameter. So, on the circle, the radius is just the distance from the center to the edge, and the diameter is the distance from the longest distance between 2 points on the circle. And so the diameter is always equal to two radii, technically. So d equals 2r. And if d is 14.9, then 2r is equal to 14.9, so r is equal to half of d. So r is equal to 14.9 over 2. And that is equal to 7.45. And so our area is going to be equal to pi times 7.45 feet squared. And you can, if you have a calculator, you can plug this in if you want, but there's really no point simplifying more than this. Squaring this number is going to be really ugly, and pi is also very ugly to deal with, so we'll just leave it like this and it should be fine. If you have a calculator, you can just find the number. It'll probably be somewhere around like 150, a little bit more probably. But yeah, for our next problem, we want to find the circumference if the radius is 6 inches. So circumference is equal to 2 pi r. And circumference on a circle is the length of its, basically the wrapper, is how long, uh, it's the perimeter of the circle, is what you would say, I guess. It's how long this outer part is. And so it's always equal to the radius times 2 pi. And so if the radius is 6, then we get 12 pi inches. And usually we like to leave things in terms of pi, because otherwise it will be a very messy number. Next, we have the radius is 20 centimeters, and it's the same thing. We just want to find the circumference. Once again, we just multiply by 2 pi, we get 40 pi centimeters. That's a horrendous pi. Okay, and that should be good. So these problems are quite simple. You just multiply by a number. As long as you know the formula, it should be quite easy. Alright, now a radio broadcasting station has a broadcasting radius of 40 miles, and what area does the radio station cover? So you can imagine the radio tower, and it covers 40 miles away. And a circle is all the points that are exactly 40 miles away. So it makes sense that this area is a circle. And so we can just use the circle formula, which is pi r squared. And 40 squared is 1,600, so we get 1,600, don't forget the pi, miles squared. Once again, all you have to do is plug in the formula. What is the area of a circle if the radius is 8? Plug in the formula. So you get 64 pi. Because 8 squared is 64, and you multiply by pi. What is the circumference of a hot plate if the diameter of the hot plate is 18? This one is you have to find, okay, so C equals 2 pi r, we know that. And we know that the diameter is equal to 2r. So we could of course find 18 is the diameter, so then r is 9, and then 2 pi 9 is equal to 18 pi. Or there's another formula for circumference, which is just d times pi. You can figure that out pretty easily because d is 2r, and so just 2r gets turned into d. That's all. It'll just save you a little step, but it's not too important. So this will end up with 18 pi. Either way, you get 18 pi. Alright, and now to some 3D geometry. We want to imagine if we have a right square prism. So a right prism just means that the top and the bottom squares are right on top of each other. So we can imagine that this, like the centers are perfectly aligned. And then a plane parallel to its base. So a plane is like, a big sheet, so parallel to its base, cuts right through it. So what happens if we get cut right through it like that by a plane? So it gets cut right through here. So what is the shape of the part that gets cut through? What is the intersection? It's going to end up being a square. Um, a square. It's going to be exactly the same as the base, except it's wherever the plane cuts it. You can kind of just imagine that in your brain. Very similar for the hexagon. If we have a hexagon, my 3D drawing skills are not perfect, so excuse me. But hopefully you can understand the rough shape of the hexagon. There's like these lines back here, and there's like these lines here. And then if you get another plane that cuts right through it, it'll cut right through, and you'll get another hexagon shape. And once again, it'll be exactly equal to the base, except shifted. It'll be congruent because it's parallel to the base, so there's no funny business happening. Now, what if it's a tetrahedron? So tetrahedron is just 4 triangles slapped together, something that looks like that. So there's a triangle. This one is a triangle. This one is a triangle. And then there's a triangle down here. And then I'll just draw it in black again. There's a triangle over here. So there's 4 triangles. But these black and blue ones are in the back. I kind of drew them like they're in the front, but it's fine. And so if we imagine a plane that's parallel to its height, there's actually 2 things that can happen here, because it doesn't say exactly where the plane is. So the height is like the line that goes from the tip to the base. And so if we have a plane that cuts, like let's say one that goes like this, it'll cut it right here, and then you'll end up with something that looks like a triangle, because like you can imagine the little nose gets cut off. But if instead we put the plane behind the height, then instead of a triangle, we'll get something that looks more like a trapezoid. And it may not actually be a trapezoid if it's tilted, because there's a lot of different ways this thing can cut. So it could be like a weird triangle like that. It could be something a little bit imbalanced. This problem is not specific, but there's a lot of things that could happen. It's just hopefully you can try to visualize it in your head. This next one is much easier. It's a right cylinder. A cylinder and a prism are very related. They're almost the same thing, except that one of them is not a polygon. It has curved surfaces. And so a right cylinder, a right circular cylinder to be precise, once again is right, so it's right on top of the other. And it implies that it's circular. Technically a cylinder does not have to be circular, but that's usually like 99% of the time they are. So if you cut right through it, once again, the part that gets cut is going to be like that, and it's going to be a circle. It's going to be the same shape as the base. Alright, intersection of a cube and a plane parallel to the height. Once again, when we're parallel to a height, we don't know exactly the direction of the plane, because the height is just a line, so there's many different planes. Maybe I can explain that a little better. So if you have like a line here, and we want a plane that's parallel to it, basically any plane that looks like that works. It could look like that, any angle, as long as like this line is like the same. You can imagine like we have a line here, we have a plane, and then we can like rotate it however we want around. We can even turn the plane. So there's a lot of the ways you can cut it. Maybe the question is asking for it was like this, and so it'll cut out a square. But it could also be like diagonal, like a plane that looks like that, and then you'll end up with a rectangle. Or maybe you can end up with a triangle, I'm not sure. No, I don't think you can end up with a triangle, but you can definitely end up with a rectangle. Alright, and now what about a sphere on a plane? Well, this one, a sphere is perfectly symmetrical, so if you just imagine cutting through it like that, if that's the plane, you'll end up with, you'll cut off like a little cap of the circle, of the sphere I mean, and in that cap, the shape will be a circle. And depending on how far left or right you cut it, it will be bigger or smaller. And then lastly, a right square pyramid, so something like that, and a plane parallel to its height. That depends again. If you have it like straight on like that, then we'll end up with a trapezoid. But if we have a plane that cuts like that, then we'll end up with a triangle. I think there's a few more questions down here. A cone and a plane parallel to its base. Once again, cones can technically be non-circular, but we're going to assume it's circular, and it says that it's right. and a plane parallel to its base will cut along like that, or like that, and then we will end up with a circle. And how high up you go will determine the size of the circle. And then what would be the intersection of the right cylinder and a plane parallel to its height? So if you go parallel to its height, it's going to cut something that looks like that, and so it's going to be a rectangle. And then if you go to the center, it'll be a wider rectangle. And yeah, I believe that's the only possibility. So that wraps things up for today. Thank you for listening. Goodbye.